So section 6.2 talks about parallelograms, and parallelograms are kind of like the top tier of a polygon family tree. Underneath parallelograms, there's also rectangles, rhombus, and square. We're going to look at all of those, but for right now, we're going to start with just parallelograms and properties that are apply to all of those, but they're the only ones that apply to every single parallelogram. So the first initial definition is if a parallelogram, then opposite sides are parallel. In a four-sided shape, the opposite sides are parallel, making it a parallelogram. So here's our parallelogram, and we're going to mark that they're parallel by drawing arrows. And that's all we know, and as long as we know that, we're good. And we're going to write the statement if parallelogram, and I'm going to draw a parallelogram instead of writing the word, then opposite sides are parallel. So again, we're going to use a lot of abbreviations, but this is going to be our if-then statement. And we're going to try and relate that statement to every single one of these properties. If parallelogram, then all five of these properties. So here's the first one. Oh, hang on. Opposite sides are parallel. We already saw that. And these five need to be written down. They need to be memorized. There will be a properties quiz that you have to be able to understand these. Opposite sides are parallel. Opposite sides are also congruent. So let's start marking some of this. So parallel. Along with being parallel, opposite sides are also congruent. Then we have opposite angles are congruent. So the angles across from each other are congruent. We also have that consecutive angles are supplementary. So if I call this one 60 degrees, the angle next to it is 120 degrees because 60 plus 120 add up to 180. And then our last one is diagonals bisect each other. If I take a second and I draw in my diagonals, they bisect each other so that this one here is congruent over here, and then over here is congruent over here. So those five properties have to be memorized. We have to be able to use all five of those easily so that we can be able to get working through this without any issues. So let's complete these statements based on this picture. LQ is congruent to, so LQ is part of a diagonal, it's congruent to the other part of the diagonal, QN. Angle LMN, this angle over here, is congruent to its opposite angle, angle LPN. Then we have MN is congruent to its opposite side, LP. Angle NPM, let's change colors. NPM, we're talking about this angle right here. Well, because it's a parallelogram, we have parallel lines, alternate interior angles are congruent. So NPM is congruent to LMP. And angle LPN is supplementary to, we have a choice of two angles. Because we're talking about this angle here, our two supplementary angles can be here or here. I'm going to use this top corner, MLP. Okay, so take a look at this picture. My goal is to find angle WZY. WZY is this big angle over here. I know this angle here is 120 degrees. 120 plus 60 add up to 180. Just an extra step. Let's find A, because this and this are across from each other. 2A equals 30. So A is 15. I know it doesn't ask it in this problem, but it couldn't hurt to practice that. So in example 3, In parallelogram EFGH, FG is this, EH is this, and so on. This problem gets very difficult if there's not a picture. Let's draw a picture, let's label everything. EFGH, it doesn't matter where you start, as long as you go around the shape in clockwise or counterclockwise order. So FG is 3x plus 1, EH is 19, EFG, this angle here is 3a plus 5, and GHE is 50. So I know opposite sides are congruent. So I know 3x plus 1 equals 19, 3x equals 18, so x is 6. I also know opposite angles are congruent. 3a plus 5 equals 50. So that means 3a equals 45. So I get a to be 15. Now remember, there are some problems where you will have to plug this back in. You will have to find angle measures. This problem's not asking to, so that's okay. Let's use parallelogram LMNP in the picture to find each measure. So PLM. PLM is this angle, which is across from this one. And 42 plus 66 is 108 degrees. Angle LMN is adjacent or consecutive with a 108 degree angle. So 180 minus 108 gets us 72. So angle LMN is 72. And I need to find D. This side is congruent to this side, so 2D equals 22. So D is 11. And our last example, this is one that's very similar to an ACT type question. Parallelogram ABCD has the following vertices. We need to find D. We have the other two, or the other three, we need to find D. So A is at 2, 5. B is at 6, 6. A, B, C is at 4, 0. And I need to find D. So as you go through this and you look, what I know is that opposite sides have to be congruent. So this side over here has to also be parallel to CD, because along with congruent, they're also parallel. So if I go to find my slope here, rise over run, the slope here is up 1 over 1, 2, 3, 4. The slope is 1/4, which means the slope from C to D also has to be 1/4. So I'm going to actually get two possible spots, up 1 over 1, 2, 3, 4. Let's call that D1. And then down 1 to the left, 1, 2, 3, 4. We'll call that D2. So now you need to ask yourself, is it going to be D1 or D2? All right, I'm going to draw one parallelogram. We'll talk about it. So there's AB, DC, and then let's go in black. This one. Now the one in purple and the one in black are both parallelograms. They are, but which one's right? That comes down to this. The parallelogram ABCD means you have to go in order ABCD. So I have to go from A to B to C to D. So the correct one is the one in black. The one in purple is actually wrong. I'm going to try erasing some of that just so we don't use that as our right answer. Okay?